Hello students, in the last class I explained the numericals on mechanical properties of solids, and today class I will discuss some more problems based on the chapter mechanical properties of fluids. So see the first problem. So in the first problem, and this is based on the concept Pascal's law. We have studied the application hydraulic lift. So in that hydraulic lift, you know that this is area of cross section A1, and here the area of cross section of second piston, that is A2. In this we have filled an incompressible ideal fluid, right? So force acting here is, we are considering as F1, force acting on this piston. So then the increased pressure will transmit through every portion, every point of the liquid, and here what pressure is acting means that is delta P. So based on this concept, you came to know that F2 value is equals to, the force acting on the second piston is equals to F1 A2 divided by A1. And here what is given? The mass of the car is given. Mass of the car is 1350 kg. And this radius is given 15 centimeters. Second, R2 radius. R1 radius, let us consider that is a 5 centimeter. So if the mass of the car to be lifted, so suppose here there is a car, we have to lift that car, then what should be the force applied on the first piston? So F1 value we have to find out. For that F2, here what is present? Car, right? That weight, that force, I can write it as M into G is equals to F1. Here pi R2 square divided by pi R1 square. The pi and pi will get cancelled. And substitute the values and find the value of F1. F1 is equals to, you can write it as mg as it is, R1 by R2 whole square, or F1 is equals to mg, m value is 1350 kg multiplied by 9.8, right? Multiplying R1 by R2. R1 by R2 means R1 is 5 centimeter, R2 is 15 centimeter. 5 by 15. 5 by 15 whole square. So here 1 times, here 3 times. Calculate this value. How much you will get checked. So finally, you will get the answer. F1 is equals to 1.47 into 10 to the power 3 Newton. And the next problem. In the next problem, if the atmospheric pressure is 76 centimeter of Hg, means mercury, I have studied in a barometer. At what depth of water in the lake the pressure becomes 2 atmospheres nearly? That means atmosphere 76 centimeter Hg means, what is the meaning? In a beaker we have that means in a trough of mercury, if we invert the glass tube, then the level of the mercury from this surface we got, that is 76 centimeter, right? That means 1 atmospheric pressure, we can also say that it is a 76 centimeter of mercury. Then let us consider this the top surface of the water, and you know that at the top surface the pressure is P0, that is 1 atmospheric. I can consider on the top surface the pressure acting is 1 atm. We have to find at what depth the pressure becomes 2 atm or 2 atmospheric pressure. Suppose at this point I will consider the pressure becomes 2 atm. That means on the surface P0, that is 1 atm. From this point to this point, what should be the pressure? Again it should be P0. Then on the top surface plus up to this point, P0 plus P0, that is 2 P0. So from this point to this point, what the variation of pressure means? From this point to this point, the variation of pressure is rho g h. Then if I substitute the value here, I will get P naught is equals to rho, that is density of water 10 to the power 3, acceleration due to gravity, take 9.8 meter per second square, and h. And we know that the value of P naught also, the value of P naught is how much? 180 m, and the P naught value is equals to 1.013 into 10 to the power 5 Pascal, right? So that value substitute here, 1.013 into 10 to the power 5 Pascal. Then you can able to find the value of h. So calculate this one. So here 10 to the power 5, 10 to the power 3. If it comes this side means 10 to the power 2, 10 to the power 2, and here 9.8. So 1.013 into 10 to the power 2 divided by 9.8. Check this value. Finally, you will get the answer, that is 0.1033 into 10 to the power 2 meters. Or we can write the final answer is 10.33 meter. 10.33 meter in centimeter means you will get the answer 1033 centimeter. And in the next problem, the pressure at the bottom of lake due to water is 4.9 into 10 to the power 6 Newton per meter square. What is the depth of the lake? Similar type problem. So let us consider this is the lake, and somewhere at this depth, okay, at this depth let us consider the pressure is 4.9 into 10 to the power 6 Newton per meter square. So we have to find the depth of the lake at the bottom of the lake due to water. So due to water means consider from this point to this point, no need to consider atmospheric pressure, okay. Then why? Because in the question itself we mentioned due to water column, the pressure at this point is 4.9 into 10 to the power 6 Newton per meter square. Again, P is equals to rho g h. P is equals to rho g h means if you substitute the value, you will get pressure is 4.9 into 10 to the power 6 Newton per meter square. This equals density of water 10 to the power 3, and here this value is 9.8 into height h. That height or depth we have to calculate. So if we calculate, you will get 4.9 divided by 9.8. So here 10 to the power into 10 to the power plus 3 you will get. This is the value of h. Then h is equals to here 1 times, here it will become 2 times. 1 by 2 means 0.5. 0.5 into 10 to the power 3 means you will get 500 meters. The depth of the lake is 500 meter. At that depth, the pressure is 4.9 into 10 to the power 6 Newton per meter square. So next, fourth one. Let us from here make it as 4, 5 like that. An inverted U-tube has its 2 limbs in a water and kerosene contained in 2 beakers. If water rises to a height of 10 centimeter, to what height does kerosene? So this problem consider and U tube. Okay, like this U tube let us consider. So one limb of this glass U-shaped tube is dipped in water, and the height of the water level one side, that is given as 10 centimeter, and the other limb is dipped in kerosene. So here we have to find what is the level of the kerosene in the other end. This H value we have to find out. Okay, for this which formula we have to apply? You can use rho 1 H1 is equals to rho 2 H2. Why? Because on both the beaker the atmospheric pressure is same only. The height of the liquid or this height of the water has to balance the atmospheric pressure, or we can say the weight of the liquid column here has to balance the atmospheric pressure. Here also the weight of the liquid column, water column, has to balance the atmospheric pressure. So atmospheric pressure is same, means rho GH is constant, means we can write rho 1 H1 is equals to rho 2 H2. Rho 1 in CGS system is given every unit, that's why here also I will consider the density of water is 1 gram per centimeter cube, and H1 is given 10 centimeter. This should be equal to rho 2 value is given 0.8. We have to find H2. So in SI system means the density of water, that is 1000 kg per meter cube. Here every units is given in CGS system, right? So the density of water I have written in CGS system. In CGS system, remember that is 1 gram per centimeter cube or cubic centimeter. So similarly I substituted all the values and find out the value of H2. The value of H2 you will get 10 divided by 0.8. 10 divided by 0.8, that you will get nearly 12.5 centimeter. This is the answer. Yes. In the next problem, a liquid is flowing in a cylinder pipe of internal diameter 4 centimeter with a velocity of 5 meter per second. If this tube is joined with another tube of internal diameter 2 centimeter, then the velocity of flow of liquid in the smaller tube will be. So let us consider this diagram. In a cylindrical pipe, the liquid is flowing and its diameter value is given. In the cylindrical, its diameter value is given, that is 4 centimeter. And what is the speed of the fluid elements or liquid here? The speed is given. Let us take V1, that is 5 meter per second. If this tube is joined with another tube of internal diameter 2 centimeter, okay, like this, another tube is joined to the first tube and the internal diameter of the tube, let us take it as D2. D2 is mentioned as 2 centimeter. Then here we have to find the velocity of velocity of this liquid or fluid. V2 velocity we have to find. V1 is given. Here D1, let us consider this diameter is D1 4 centimeter. Here diameter is 2 centimeter. Which formula we have to apply? That is equation of continuity. What is that one? A1 V1 is equals to A2 V2. Volume rate flow constant. That means up to here the velocity become 5 meter per second only. Why? Because the area is not changing, but here the area is changing, hence the velocity also changes. So we can apply this formula, A1 V1 is equals to A2 V2. Here A1 pi R1 square into V1 is equals to pi R2 square into V2. Pi will get cancelled, diameter is given, that means this radius is equals to d by 2, half of the diameter. You can consider this is d1 by 2 into v1 whole square is equals to d2 by 2 whole square into v2. Here this 2 will get cancelled. Then you can write it as d1. d1 value is 4 centimeter square. 4 centimeter square means here 4 square into v1 is equals to d2. d2 value is 2 square. 2 square into v2. v1 value also mentioned. v1 value is 5 meter per second. So here centimeter will get cancelled. No need to mention in meters. Then how much you will get the answer? So 16 into 5 is equals to 4 into V2. Okay, then 4 ones are 4 4s are V2. You will get the answer 20 meter per second. So in this way we have to use the equation of continuity formula. So the speed in the smaller tube, that is 20 meter per second. And next problem. In the next problem, the velocity of the wind over the surface of the wing of an aeroplane is 80 meter per second and under the wing 60 meter per second. If the area of the wing is 4 meter square, the dynamic lift experienced by the wing is Bernoulli's principle. Okay, let us consider this is the wing and upside what is the speed of the air, speed of the wind. Let us say V1, the speed of the wind upside, that value is given 60 meter per second, and in downwards V2, that is in upward, that is 80 meter per second. Under the wing they given 60 meter per second. If the area of the wing, this area of the wing, let us consider it as 4 meter square. This is the area of the wing. We have to find the dynamic lift experienced by the wing. So you know that due to difference in pressure, there is a net upward force will act. That net upward force is nothing but dynamic lift that creates due to difference in pressure. So for that we can apply the Bernoulli's equation. So the wing is at same height means we can consider, you know that this is the formula, right? P plus rho gh plus half rho v square is equals to constant. This is Bernoulli's equation for flowing fluid. So we can neglect this rho gh. Why? Because the IT is same. Directly you can consider P plus half rho v square is equals to P plus half rho v square is equals to constant. Then you can write P1 plus half rho v1 square is equals to P2 plus half rho v2 square. Then so you know that where the pressure is maximum, that means where the velocity is less, there pressure is more. That means below the surface P2 pressure above, let us consider P1 pressure, then P2 becomes greater than P1, hence there will be a net upward force. So we have to find the value of P2 minus P1. This is a difference in pressure. I can able to write delta P, difference in pressure. Now P2 minus P1 becomes, you can see here, of rho, if you take common outside, you will get V1 square minus V2 square. So here you substitute the values. So this equals 1 by 2, density of the air is given, density of the air is 1.3 kg per meter cube V1 square, 80 square minus 60 square. So find the final answer. So delta P, difference in pressure, becomes 1.3 by 2. Here you will get 6,400 minus 3,600. Here delta P becomes 1.3 by 2. Here 64, 36, that means 8, 2,800 you will get, right? This is 2,800, here 1 times and here 4 times, that means 1,400. Then delta P value is equals to 1,400 into 1.3. So find this value. Yes, here delta P value you will get, that is 1820 Pascal. Then you know that formula, pressure is equals to force by area. So here force means I will consider it is pressure is nothing but the difference in pressure into area, delta P into A. Then F is equals to delta P value we got 1820 and area means here how much is given, 4 meter square multiplying by 4. So the final answer you check, that is you will get 72800. Why? Because 18 force here 72,800 Newton you will get. That is fourth option. And in the next problem, there is a hole at the side bottom of big tank. The area of the hole is 4 millimeter square. Throughout it a pipe is connected. The upper surface of the water is 5 meter above. The rate of flow of water through the pipe is. So you can consider this diagram. This is a big tank. This the side bottom, at the bottom of the side bottom of the big tank. So you can consider like this. The height of the liquid, the height of the water is given, that is 5 meter, and this area of cross section, here there is a pipe. So for this pipe, the area of cross section is given, that is 4 millimeter square. We have to find the speed of the liquid in this pipe. The rate, not speed of the liquid, what he is asking means the rate of flow of water, the rate of flow of volume flow rate we have to calculate. So volume flow rate we have to calculate means we have to find at what speed the water is coming out, speed of efflux. We have studied in Torricelli's theorem, the speed of efflux formula you got, that is V is equals to root over 2GH. Okay. Then what is volume flow rate formula? Volume flow rate formula is equals to A into V. So first you have to find the value of V, next you have to substitute here. You can able to find the rate of flow of water or volume flow rate. So let us first calculate this value, root over 2GH, 2 into Here G value we mentioned to take 10 meter per second square, and H we have to consider it as 5. Then here 10 we will get the V value is 10 meter per second. Okay, so at this point the speed of efflux of water, the speed at which the water is coming out from this opening, that we got 10 meter per second. And volume rate flow, here the area is how much? 4 millimeter square, right? So here volume flow rate to find, area is 4 into 10 to the power minus 6 millimeter square into 10 meter per second. Then the answer you will get 4 into 10 to the power minus 5 meter cube per second. This is the answer. And the next problem, 8th one. See, in this problem, a metal plate of area 500 centimeter square is placed on a glycerine layer of thickness 5 millimeter, and coefficient of viscosity is given 2 Pascal second. The horizontal force required to move the plate with a velocity of 5 centimeter per second is in Newton. We have to find the answer. So we know that viscous formula, the force of viscous depends upon coefficient of viscosity, area, dV by dx. So here in the glycerine there is a metal plate, means suppose consider this is the metal plate. To move this metal plate, you know that the drag force is acting in opposite direction, so this much force is needed, that is F equals eta A dV by dx, where dV by dx is called as velocity gradient. So substituting the values, we will find how much force is needed. That is F equals coefficient of viscosity is 2, area is 400 centimeter square, 400 into 10 to the power centimeter square, I am converting into meters, 10 to the power minus 4. This is area. And dV means infinitely small change in velocity, that is dV. Here what is given? dV is 5 centimeter per second change in velocity. So divided by dx. Dx means what? That thickness 5 millimeter. 5 centimeter per second means here 5 into 10 to the power minus 2. I am converting into meter per second, and also here 5 millimeter, 5 into 10 to the power minus 3. So everything is in SI system. Then you can able to find the force you will get in Newton. So here 2 into this 5 and this 5 will get cancelled, 10 to the power minus 3 will become plus 3, plus 3 means 1, here plus 1 minus 4 means minus 3, minus 3, 400 into 10 to the power minus 3 you will get, and here 2 zeros means you will get minus 1, and 2 4s are 8 into 10 to the power minus 1 means final answer you will get 0.8 Newton. So this is the final answer. This much of force is needed. So before solving the problems, you have to understand the concepts clearly. Then you can able to find that means you can able to apply the formula. Then you can able to get the solution. And in the next one, Next problem. The length of wire floating on a water is 5 cm. The force needed to pull the wire out of the water is in Newton. The tension of the water, the surface tension of the water is mentioned. So the ninth problem, consider this is the surface of the water. You have studied about surface tension. That surface tension formula T is equals to F divided by L, force per unit length. Let us consider there is a wire, right? There is a wire. That wire is floating on this surface of the water. Let us say this is the top surface of the water. On the top surface of the water, like this, a lightweight wire is floating. In this way you can imagine the diagram. That means it is floating means that is due to surface tension force, and that force, that surface tension force is mentioned given as T is equals to F divided by L. So to pull this wire out from the surface of the water, definitely we have to apply some force additional to the weight of the wire. Okay, remember we are calculating how much additional force we have to apply, that is how much force we have to apply additional to weight of this wire. So here in the case of wire, like this, in the case of wire, or if you bend it, you can make that as a ring. Okay, wire or ring, anything you consider. So how many surfaces we have to consider means we have to consider two surfaces. So in the case of ring, you can able to see inner surfaces and outer surface. In the case of rod or in the case of wire, also you can consider this is for one surface and this is other surface. I hope you understood. You have to consider in case of wire and in case of ring, two surfaces you have to consider. For that, in the formula, the effective length becomes, especially for wire, rod and ring, okay, the effective length becomes 2L. Remember this one, T is equals to F divided by 2L. Then we will substitute the values and we will calculate the force. T into 2L, I can able to write it is F equals T into 2L. Then F equals, the surface tension value is given 7.2 into 10 to the power minus 4. Multiplying by 2, length is 5 centimeter, 5 into 10 to the power minus 2. Then you calculate, you will get F equals here minus 4 minus 2 minus 6, and here 10 minus 5, you will get 7.2 into 10 to the power minus 5. Let us make it as here it should be 10 to the power minus 5. The option is second option. The force required is 7.2 into 10 to the power minus 5 Newton. And what about in case of circular disc? I said for wire, rod and ring, the effective length you have to consider as 2L now. Why? Because it wets two surfaces. In case of circular disc, okay, this is ring, this is circular disc or circular plate. In that case we can able to consider the surface as only one surface. Here in case of circular plate, it wets only one surface, while in case of wire, rod, ring, it wets two surface. Hence in the formula while writing here we have to write for these F divided by 2L. So this is important for competitive exam, remember this point. So by this, this mechanical properties of solids, fluids and some example problems useful for competitive exams is completed. Now from the next class, I'll start a new chapter. Thank you.